Good day everyone, I am Naisamani. So the assigned topic for me is about exponential distribution. So exponential distribution is one of the widely used continuous distributions. It is often used to model the time elapsed between events. So if the Poisson distribution deals with the number of occurrences of events in a fixed period of time, ang exponential distribution naman ay minimeasure niya yung expected time for an event to happen. So, a continuous random variable x is said to have an exponential distribution with parameter lambda is greater than 0. So, the exponential distribution formula will be given as follows. So, let's move on to the expected value and variance of variable x. So, for the formula of expected value will be like this. Expected value of x is equals to 1 over lambda or equals to mu. And for the formula of variance, it will be variance of x is equals to 1 over lambda squared or mu squared. So this figure shown the PDF of exponential distribution for several values of lambda. So for us to understand more about exponential distribution, let's have some examples. So example number 1, assume that the length of a phone call in minutes is an exponential random variable x with parameter lambda equals 1 over 10. So if someone arrived at a phone booth just before you arrived, find the probability that you will have to wait less than 5 minutes. So first thing we should do is compute probability of x less than equal to 5 with lambda equals to 1 over 10. So we will use this equation. So this will be probability of x less than 5 equals 1 minus exponential of negative 5 times 1 over 10 equals to 1 minus exponential of negative 5 over 10 equals to 1 minus exponential of negative 0.5 equals 1 minus 0.6066. So, the result will be 0.3934. So, example number 2. The article probabilistic fatigue evaluation of riveted railway bridges suggested the exponential distribution with mean value 6 megapascal as a model for the distribution of stress range in certain bridge connections. Let's assume that this is the true model. The expected value of x is equals to 1 over lambda equals 6. Implies that lambda is equals to 0.167. The probability that stress range is most 10 megapascal is. And next question is find the probability that the stress range in between 5 and 10 megapascal. So first, let's have the solution for our first question. So for our solution, probability of x is less than equal to 10. So our x will be 10 and our lambda is equals to 0.1667. So this will be equal to 1 minus exponential of negative 0.1667 times 10. So this will be 1 minus 0.189. And the final result will be 0.811. So for our next question, find the probability stress range in between 5 and 10 megapascal. So our solution will be like this. Probability of 5 is less than equal to x and x will be less than equal to 10. So the value of our x will be 10, and 5, and our lambda is 0.1667. So this will be 1 minus exponential of negative 1.667 minus 1 minus exponential of negative 0.8835. So the final result will be 0.246.